here we are for the 3-day webinar series on units in engineering and scientific calculation. So this is our second day. So before starting the section formally, so I like to share some of the instructions to be followed throughout the webinar. So once you get into the page, kindly mute your audio and video. It is mandatory and it will enhance the quality of the webinar. So everyone can hear and see the speaker presentation alone. So wait for the resource person to present his screen. So once the presenter presents his screen, it automatically displayed on your screen. So if you are spinning any other screen, kindly pin the presenter's screen. So in case you have any questions, query, you can type the same in the chat box, or you can unmute yourself and ask the query at the end of the session. So if you accidentally leave the meeting, you can rejoin the meeting using the same link. So we expect your fullest cooperation throughout the webinar. The feedback link will be shared only at the end of the section. So thank you. So now I like to welcome Mr. S. Sridharan from third year mechanical engineering to propose the welcome address for the today's webinar.
Very good evening to all and all here. On this auspicious occasion, I would like to welcome you all for the second day of the 3 days webinar series entitled Units in Engineering and Scientific Calculations. And today's topic is Units in Design. Success is not a final, failure is not a fatal. It is the courage to continue that counts. With this quote, it's our pleasure to welcome one of the success courageous person, Mr. C. Gururaj, Assistant Professor, Mechanical Engineering, Ramco Technology, who is our today's presenter of this webinar series. The essence of great leadership is influence, not authority. With this note, I like to welcome the respected principal of our institution, Dr. L. Ganesan, to this webinar. We celebrate our leadership and you will keep on influencing us with us. Welcome you, sir. It is our honor to welcome the Vice Principal and the Head of the Department Mechanical Engineering, Ramco Technology, who put his soul and the heart in uplifting others, attains dignity. We welcome you, sir. I would like to welcome the Faculty Coordinator of IE, Mr. J. Jabin, Assistant Professor, Mechanical Engineering, Ramco Technology, who is giving us the opportunity to conduct this type of event and welcoming the student coordinator. Finally, I sincerely welcoming all my student friends. You are strong and smart. Once again, I welcome you, everyone, today's webinar. Thank you.
Thank you, Sridharan. So next, I would like to welcome Mr. J. Jabin, Assistant Professor, Department of Mechanical Engineering, Ramco Technology, to say a few words about the today's chief guest of the webinar.
So thank you for this. So good evening to everyone. So before starting the session, I would like to say a few words about our expert speaker of today, Mr. C. Gururaj, sir, Assistant Professor, Senior Grade Mechanical Engineering. He completed his BE Mechanical Engineering, Ramco College of Engineering in the year 2005. He completed his MA Engineering Design in College of Engineering, Guindy in the year 2010. And currently he is doing his research in fracture mechanics. During his earlier days, he worked in Carborundum Universal Limited, Hosur. His research areas are fracture mechanics, metal matrix composite, polymer matrix composite, and he has also published 8 conference papers and a journal paper. He is also a recognized certified Microsoft Innovative Educator, which was given by the Microsoft Education Community. He has also completed numerous online courses. He has also delivered many guest lectures. So with this short intro, now I would like to hand over the session to our expert speaker today, Mr. C. Gururaj, sir. So Gururaj, sir, you can take over the session now.
Yes, sir. Yes, sir. Thank you, Mr. Jabin, for the nice introduction. First of all, I would like to thank our management and the principal, vice principal, to give me this excellent opportunity to speak on an online platform about units of scientific calculations. Right. So I also convey my thanks to the faculty coordinators of Institution of Engineers and IST student chapter, and the faculty coordinators and the student coordinators of that forum to give this opportunity. Thank you. So now I am sharing my okay. So today's topic is units in engineering and scientific calculations. So units in the sense it's very important for engineering subject, right? So nothing unit, there will be no calculations in the engineering subjects, right? So if you have, if you do, if you put any mistakes during handling the units, so the answer will be wrong. Already we know, right? So so these are all the topics I am going to cover today, right? So first of all, we have to know the rules and conventions for writing SI units. Nowadays, we are using SI units. So globally, we are following SI units only, right? So we know the symbols of the SI units, right? But we don't know the rules and conventions for writing the SI units, right? So today itself, till now also, we are writing the SI units as wrong only. In some books also, they have given the SI units in the wrong manner only, right? Not all the books. So some books, they have given the SI units in the wrong manner, right? So then, what are the prefixes used in SI units? What are the prefixes used in SI units? What is SI units? So some fundamental units are there. Already we have discussed it, right? So Suresh Sir have discussed yesterday webinar. So what is SI? Some fundamental units are there. So that is meter. For length, the unit is meter. For mass, so that is gram. Okay, so these are all fundamental units. So there are 7 fundamental units are there. So that unit, some prefixes are used. For example, so meter means millimeter. So 1000 millimeters are equal to 1 meter. So that milli is called as prefix, right? Milli, centi, deci, mega. There are prefixes used in SI units. We will see very elaborately in the forthcoming slides, right? So then we have to discuss. After that, we have to discuss unavoidable units in engineering calculations and conversions. There are so much of units are there. So within a short time, we have to discuss some of the units which are used in our engineering calculations. So we are studying some thermo subjects, the manufacturing subjects, some design subjects. So these subjects are having some problematic purpose. In the problematic purpose, we have to handle units very correctly. Otherwise, the answer will be going to wrong, right? So what are the units we are going to use? So that units, that familiarized units, we have to discuss, right? We are going to discuss in today's webinar, right? Then units derivation in equations. What are the some equations? For example, equations of motion. So left hand side, one physical quantity will be there. The right hand side, one physical quantity will be there. The unit of left hand side should be equal to the unit of right hand side, right? Otherwise, the equation is immaterial, right? So we are going to see about that also, right? First of all, the rules and conventions for writing SI units and their symbols, right? So the units of scientist's name, some units are having scientist name itself, right? So for example, Newton, Henry, Watt. So that units are not written with a capital initial letter. The first letter of that the unit will not be capital letter. So if you want to write the unit of force as Newton means, so we have to write Newton as it is, right? We have to use the first letter as small letter only. If you want to use Newton as the unit, sometimes we are going to use some letter as a unit. So that is N, capital N, right? So on that time you have to use capital letter only, right? You should not use small letter, right? This is the first rule, right? The symbol of the units of scientist name should be written by capital letter only, right? Not in small letter. So for example, N for Newton, W, capital W for Watt, right? And so on. Okay. So this is the first rule. So second, small letters are used as symbols for units not derived from a proper name. If the units are not having the scientist name means that letter, the symbol of that units should be in small letter only, should be in small letter only. So for example, so for meter we have to mention small m, right, small m for meter. So kg for kilogram. So most of our students are using capital K for writing kg, right? So this is, so in this way they are using, right? So this is wrong. Okay, so you have to use small k and small g. So this is kilogram, right? So meter, so you have to use small letter m. You have to use small letter m. Okay, so otherwise that will be wrong. Okay, so no full stop or other punctuation marks should be used within or at the end of the symbol. Okay, so in the no other punctuation mark should be there, right? So that is, so 50 meter means, so 50 meter, that's all. So not 50 meter and then one dot. So this is wrong. Okay, so 50 meter, so you have to mention 50, some space and then meter. So this is the right way to mention the units, right? Then next one, when temperature is expressed in Kelvin, so there are so much of unit for temperature. So Celsius and centigrade are same. Celsius and centigrade are same. So Fahrenheit is also there. So in SI units we are using Celsius and Kelvin. We are commonly using commonly Kelvin and Celsius for temperature unit. Right? So when temperature is expressed in Kelvin, the degree sign is omitted. So Kelvin is a scientist. So that's why we are going to use the capital letter K, capital K, okay, uppercase letter, capital letter K. So 273 Kelvin, not as 273 degree Kelvin. Okay, so this is the right way. So when temperature is expressed in Kelvin, the degree sign is omitted. You should omit the degree sign during mentioning the temperature, right? So then if expressed in Celsius scale, degree sign is to be included. For example, 100 degree C, not 100 C, right? So this is another meaning. So 100 C. So degree Celsius means, so you have to mention the degree sign. So in Kelvin, you should not use degree. Use of slash. So in some other unit, for example, meter by second. So some division is there in that unit, right? In that situation, we are normally we are using slash symbol, right? Use of slash is recommended only for indicating a division of one letter unit. Okay, one letter unit. What is one letter unit? So meter by second. So meter by second. So meter is one letter unit. So second is another letter unit, right? Meter by second. This is small s, right? So slash is recommended only for indicating a division of one letter unit symbol by another unit symbol. Not more than one slash is used. So for example, so this is joule per kilomole. Joule divided by kilomole, right? So here the K is, Kelvin mole, So K is for Kelvin, capital K. Capital K is for Kelvin, joule per Kelvin mole. Or we have to mention joule Kelvin power minus 1, mole power minus 1. So this is the right way. So you should not mention joule per Kelvin per mole. So this is wrong, right? This is wrong. It will leads to some confusion. What's the this last symbol is what for, right? So it will be equal to joule per. So it will be equal to this, or joule per K divided by mole. So what will be correct? So it will leads to some confusion. That's why we have to use this only, right? Joule Kelvin power minus 1, mole power minus 1. Otherwise we have to use this, right? Joule per Kelvin mole, right? Then some space is always to be left between the number and the symbol of the unit, and also between the symbols for compound units such as force, momentum, etc. It is, for example, it is not correct it is not correct to write 2.3 m. So this is 2.3 meter. So the correct representation is 2.3 m. So you have to write 2.3 some space and then m, right? Right. So kilogram meter second square. So small k, small g, m second square. Kilogram meter by second square are not as kilogram. So here there is no space. So this is wrong way, right? So you have to give some space between two units, right? So this is the rule. Then only accepted symbols should be used. Only accepted symbols should be used. For example, here, ampere is represented as A, right? Not for amp. We are going to, normally we are using SEC. We are using SEC for second, right? SEC for second. So the symbol for second is small s, that's all. The symbol for second is small s. So ampere, so the symbol for ampere is A, that's all, not A and B, right? So there are so much of unit we are using, now we are using in the wrong manner, right? So after this webinar, we will try to use the correct manner, right? So numerical values of any physical quantity should be expressed in scientific notation. What is scientific notation? So scientific notation is nothing but, so 1500. So what's the scientific notation for 1500? So 1.5 into 10 power 3. We have to give, we have 1.50, right? We have to give single decimal before the decimal point, left side of the decimal point, only one digit should be there. So after the decimal point, all other digits will be there, right? So into 10 power something. So here 1500 means 1.5 into 10 power 3. So this is the scientific notation of 1500, right? Numerical value of any physical quantity should be expressed in scientific notation. Scientific notations only used here, right? You should use scientific notations only, right? For example, density of mercury. So you have to mention 1.36 into 10 power 4 kilogram per meter power 3. Right, kilogram meter power minus 3. So kilogram per meter cube. So this is the scientific notation. You should not mention 13,600 kilogram per meter cube. So this is wrong. So this is wrong. You have this is the numerical. It is right only. Numerical is right only. The rule is not there here. Right. So the rule is you have to mention 1.36 into 10 power 4. So this is only for eradicating the confusions. And following the standard way globally, right? So that's why we are using this type of conventions, right? Okay, so with this point, the rules, there are 10 rules. The rules are closed. So then we will move to the next topic. So that is prefixes used in SI units. What is prefixes? It is very, very important. It is very, very important. So by the prefixes only, by understanding the prefixes only, we can convert one unit to another unit, right? So this prefix is, you can use the prefixes as in meter, as well as gram, as well as Richter. So in any, in any measurements you can use the prefixes, right? So for example, we will take meter. We will take meter here. Meter means 10 power 0, that is 1 meter, right? 10 power 0 meter means 1 meter, right? So this is decimeter, centimeter, millimeter. There are 10. So here decimeter, 10 decimeter, that is equal to 10 decimeter, that is equal to 1 meter. 10 decimeter, that is equal to 1 meter. 10 centimeter, that is equal to 1 decimeter. So in between deci and centi, 110 will be there. In between centi and milli, 110 will be there. So 10 millimeters are equal to 1 centimeter. So what's the relation between centi and meter? So centimeter, so 100, here 110 is there. So here 110 10 is there. 10 into 10, that is equal to 100. So 10 centimeter, that is equal to 1 meter. So what about the relation between millimeter and 1 meter? So here 110 is there. So here 110 is there. Here also 110 is there. So 10 into 10 into 10, 1000, right? So then 1000 millimeter will be equal to 1 meter. 1000 millimeter, that is equal to 1 meter. 100 centimeter will be equal to 1 meter, right? So 10 decimeter will be equal to 1 meter. So these are all lesser units when compared to meter. So decimeter, centimeter, millimeter. These are all the lesser quantity when compared to meter, right? So that's why I am writing 1000 mm, that is equal to 1 meter. So this is very important. So prefixes. So this is prefixes. So if you go to the higher values, that is decameter. So 10 meter, that is equal to 1 decameter. 1 decameter. Yeah, that is dA. Right, dA. So milli m, centi c, d. So deca means d. So you have to 1 DAM, decameter, right? So 10. So here in between deca and meter, 110 will be there. So 10 meter, that is equal to 1 decameter. Then here also 110 will be there, right? 110 will be there. So here also 110 will be there. So what will come? So 100 meter, that is equal to 1 hectometer. 1 hectometer. So hectometer, we can write it as 1 hm, right? 1 hm. So what's the relation between kilometer and meter? We know, right? 1000 meter, that is equal to 1 kilometer. So this is the convention. If you replace the meter in terms of liter means, so that is also correct. 1 centiliter, that is equal to 10 centiliter, that is equal to 1 deciliter, right? 1000 milliliter, that is equal to 1 liter. 100 centiliter, that is equal to 1 liter. 10 deciliter, that is equal to 1 liter. That is also correct, right? So this is the common prefixes used in SI units. So then, so if you go to next to millimeter, so that is micrometer will be there. Micrometer will be there. Nano and then nanometer will be there. Up to nano we are using. Up to nano, normally up to nano we are using. So in the above table, so kilo, mega we are using, giga we are using. Nowadays we are using tera also. So that is a rare case, right? Usually we are using up to giga, right? So 10 millimeter, that is equal to 1 centimeter. So here you see, so 10 power minus 3, 10 power minus 6. So 10 power minus 3, 10 power minus 6. So what's the meaning? So this is the relation between millimeter and micrometer. Right? So 10 power 6, 10 power minus 6. So 10 power, we have to multiply. So 10 power 1. So 10 meter is equal to 1 decameter. 10 meter, 100 meter is equal to 1 hectometer. Right? So 1000 millimeter, that is equal to 1 meter. So 10 power 6 micrometer. So this is micrometer, that is equal to 1 meter. 10 power 6 micrometer, that is equal to 1 meter. Okay. Any doubt? Okay. So here 10 power 9 nanometer, that is equal to 1 meter. 10 power 9 nanometer, that is equal to 1 meter. In the same way, so here mega, 10 power 6 meter, that is equal to 1 megameter. So 10 power 9 meter, that is equal to 1 gigameter. Right? So these are all the conversion. So with this conversion, we will practice with the different units, right? In the further slides, we will discuss the basic conversions, right? So these are all the unavoidable units in engineering calculations and conversions. Basic fundamental units. So what is fundamental units? Already we have discussed it, right? So units which are independent of each other are known as fundamental units. So this is not derived from any other unit, right? This is independent unit. Without this unit, no other units are there, right? So from this unit only other units are derived, right? So that is length, mass, time, temperature, electric current, luminous intensity, right? Candela, luminous intensity and the amount of substance, that is equal to mole, right? So these are all the basic fundamental units. So apart from the 7 units, some 2 units are there, some 2 more units are there. So that is radian. So this is used for plane angle. So angles are used as radians, right? So theta degree are radians. So the degree is converted into radians by multiplying pi by 180, right? Pi by 180, right? That is radian. Then stradian also is there. So stradian is used to measure solid angles. So this is stradian, right? So normally we are not using stradians. So radian is we are usually using. So most probably we are using radian only. So then derived units, we come to derived units. So the derived units are derived from fundamental units already is in the previous slide, right? So examples of derived units are velocity. So first one is velocity, for example, velocity. So acceleration, right? These are all the derived units, right? What's the unit for area? So can you say what's the unit for area? So that is equal to, so for example, if you are having a square means, so this is one side, area that is equal to a square, or a into a, that is equal to a square. So unit for a is meter, another unit, so here also meter, so that is equal to meter square. So that's why we can conclude as, so meter squared is the unit for area. Meter squared is the unit for area, right? What's the unit for volume? Volume is 3-dimensional values, right? So if you are considering a cube means, so a into a, so a into a. So as a unit for volume, so a cube, so unit is meter cube. So if you are using meter as the unit of the length means, volume that is equal to meter into meter, that is equal to meter cube, right? So if you are using centimeter for the unit of length means, so centimeter into centimeter into centimeter, so centimeter cube, right? Centimeter cube. So 10 centimeter that is equal to 1 meter. So if you are going to convert 1 meter cube in terms of centimeter cube means, what's the answer? Anybody can say? What's the answer? So if you replace meter to centimeter means, so you have to multiply with the 100. So here meter cube is there. So 100 cube. Okay, 100 cube.
10 power 6.
10 power 6. 10 power 6 centimeter cube, that is equal to 1 meter cube. 1 meter cube, right? 1 meter cube. 1 centimeter cube that is equal to 1 by 10 power 6 meter cube, that is equal to 10 power minus 6 meter cube. 10 power minus 6 meter cube. So if you want to convert centimeter cube to meter cube means, right? Centimeter cube meter cube means you have to multiply with 10 power minus 6. 1 centimeter cube that is equal to 10 power minus 6 meter cube. Right? 10 power minus 6 meter cube. Right? So first of all you have to write in the basic convention. So what is 1 meter that is equal to 100 centimeter. 100 centimeter. Here meter cube is there. Right? Meter cube is there. For example, so A is 1 meter. Right? So 1 into 1. So 1 meter cube. What's the value? 1 meter cube. We are going to convert 1 meter cube into centimeter cube. 1 meter cube into centimeter cube. So directly you can 1 meter cube that is equal to, directly you can write 10 power 6. Right? So Suppose, so here 1 centimeter, 1 centimeter, 1 centimeter means, so answer is 1 centimeter cube, right? Answer is 1 centimeter cube. How it will become how much meter cube? So 10 power minus 6. We are going to convert centimeter cube into meter cube. First of all, you have to write the basic convention. So that is equal to 1 meter, that is equal to 100 centimeter, right? 100 centimeter. Then 1 meter cube, that is equal to 100 cube centimeter cube, right? Centimeter cube. So 10 power 6 centimeter cube. Then 1 centimeter cube, that is equal to 10 power minus 6 meter cube. So you have to write in your paper before converting the unit. So if you feel very difficult means, if you know, you can write directly. Otherwise, you have to write in this way, right? 1 meter, that is equal to 100 centimeter. 1 meter cube, that is equal to 100 cube centimeter cube. So 100 cube is 10 power 6. So 1 centimeter cube, that is equal to, 10 power 5. 10 power 5. 10 power 6, right? Sorry, pa. Right? 10 power 5. Okay, so 1 centimeter cube, that is equal to 10 power minus 5 meter cube. So this is the way, right? So how many zeros are there? So 3 and then 2. So 5 zeros are there. So you got, which one is correct?
Yes, sir. 6 only correct, sir.
6 only correct. Sorry. So 6 only correct. Okay. So 2 3s are 6. Okay. Right. Density. So density, that is equal to kilogram by meter cube. So this is the unit of density. Also unit of density, mass by volume. So this is mass by volume. Kilogram by meter cube. Sometimes they are giving kilogram by centimeter cube. In some other problems, they are giving kilogram by centimeter cube. So you have to convert, but the length are in the unit of meter, right? So that's why we have to convert density kilogram by centimeter into kilogram by meter cube. Right? Kilogram by centimeter cube, that is equal to how much kilogram by meter cube. We have to convert, right? So here numerator will be there, denominator will be there. The numerator, there is no change. So here kilogram, here also kilogram, right? The denominator then 1. So there is no change, means you have to put 1, right? So centimeter, how much centimeter cube, that is equal to meter cube? How much centimeter cube, that is equal to meter cube? How much centimeter cube, that is equal to meter cube? 10 power minus 6. So Asba, any doubt? Hello?
No, sir.
Okay. So 10 power minus 6. Okay. So 1 by 10 power minus 6 kilogram by meter cube. So 10 power again, 10 power 6 kilogram by meter cube. So this is the conversion, right? So in this way you have to convert. Right? So then velocity meter by second. So this is meter by second, right? So if you want to convert into mm by second means, what will be there? What's the answer? So first of all, we have
10 raised to minus 3.
10 raised to minus 3, right? 10 raised to. So acceleration, what's the unit for acceleration? Meter by second square. Meter by second square, right? So wait a minute. Wait a minute, please. Okay, here, so wrongly we have written, right? Then, so meter by second, so that is equal to, that will be converted into by second, right? So here, bigger quantity, so 1 meter. So here, so what's the conversion of meter to So 10 power 3, not 10 power minus 3. So 10 power 3. So divided by here, S is directly, there is no change of denominator, right? So 10 power 3 by second. Otherwise, so meter by second will be converted into meter by hour. What's the conversion formula? So M by S, that is equal to meter by hour. So numerator there is no change, 1, right? So meter by second, so that is equal to, so meter by hour, right? Meter by hour. So here there is no change. So 1. So second, what's the conversion formula for second? So 60 second, that is equal to 1 hour. 60 second that is equal to 1 hour. 60 second, this is equal to 1 hour. About 1 second, that is equal to
60 second is equal to 1 minute.
Sorry, 1 minute. Here, sorry. 60 second, that is equal to 1 minute. Okay, so here hour. So 60 minute, that is equal to 60 minute, that is equal to 1 hour. So 60 minute, that is equal to 1 hour, right? So what's the conversion? So 3600. So 60 into 60, that is equal to 3600. So 3600 second, that is equal to 1 hour, right? 3600 second, that is equal to 1 hour, right? So 1 second, that is equal to 1 by 3600 hour. 1 by 3600 hour, right? So here second, so here hour, so we have to 1 by 3600. Okay, 1 by 3600. So 3600 will go in the numerator, the next step. So 3600 divided by 1 into meter per hour. So if you want to convert meter by second to meter per hour, means you have to multiply 3600, right? 3600. If minute means, meter by minute means, you have to convert, we have to multiply 60. You have to multiply 60. So that's why I have written here wrongly 60 second, that is equal to 1 hour. Wrongly I have written, right? Thank you. Then, so this is for conversion. This is for conversion. So from the prefix only, we are going to convert this formula, right? So angular velocity. So what is angular velocity? So here meter by second. This is the unit for velocity. Angular velocity means, so this is radians by second. So radians by second. So if your particle is rotating in a circular path, means, so that velocity, the velocity of that particle is called as angular velocity. So that is radians per second, right? So radians, so some degree will be there. So this is theta, means theta, that is equal to 30 degree means. So what's the conversion formula for degree into radian? So 30 degree, that is equal to 30 into pi by 180. So pi by 180 is the conversion formula for degree to radian, right? Degree to radian. So 30 into pi by 180. So 30 to pi by 180, this much amount of radian. So if you that particle will go in this way, so that is equal to for 1 second. For 1 second, it will move 30 degree means in 1 second it will move 30 degree means So what's the angular velocity? 30 into pi by 180 divided by 1, right? So this is the angular velocity of that particle, right? Angular velocity. So then angular acceleration, so this is radians by second square, radians by second square. This is the unit for angular acceleration. This is the very important unit, derived units from the fundamental units, right? So if you have any doubt, please right. So this is so this is another type of some velocity, right? Some speed. So what is speed rate? So depth of cut means in manufacturing engineering, in the lathe, we are going to cut the circular workpiece by means of our HSS tool, right? So how much amount of depth we are going to give for cut the workpiece, that is depth of cut. So this is length of workpiece. So the unit of depth of cut is only mm or meter or any other length unit, right? So this is mm. So what is speed rate? What is speed rate? It's a distance travel per second of the tool, right? The tool, that is speed rate. How much length will be traveled? So the tool, how much amount of travel will be there for tool, right? So this is speed rate, right? So for example, so 10 meter per minute. So this is the feed rate of tool means. So 10 meter by minute is the feed rate of tool means. So feed is for 1 minute. For 1 minute, the tool will move 10 meter. For 1 minute, the tool will move 10 meter. So this is the meaning. This is the meaning. So if you want to convert into mm by second means, so 10 meter by minute, that is equal to mm by second. So what's the conversion unit? So we know 60 second, that is equal to 1 minute. 1 minute. Here 1 minute is there. 1 minute is there. So second will be there. So here I will put 60, right? So 10 meter by minute. So meter. So this is meter. So here mm. So this is meter. Here mm. So 1000 mm, that is equal to 1 minute. 1000 mm, that is equal to 1 minute. Already here 10 will be there. So already 10 will be there. So 1000 mm, that is equal to 1000 mm, that is equal to 1 meter. So here 10 meter. So 10 into, so 1 meter, that is equal to 1000 mm. So 1000, we will put 1000. So this is the conversion method for here, right? So you can multiply with here. So 1, 2, 3, 4 divided by 60 mm by second. So this will be equal to 10 meter by minute. Okay, 10 meter by minute, right? So what is RPM? So this is revolutions per minute. Revolutions per minute. So in a motor, in electrical motor or in an engine, so the spindle is running, right? The spindle is rotating. So this is revolutions per minute. For 1 minute, how many revolutions are there? That is RPM, right? So if the motor is 6000 RPM means, so for 1 minute it will take 6000 revolutions. Though that is, so 6000 revolutions, there is no unit for revolutions. So divided by minute, 1 by minute. So 6000 1 by minute. If you want to convert, so 6000 RPM into 1 by second. RPS, revolutions per second. So 1 by second. So what is the conversion unit? So here 6000 is there. So 6000 divided by here 1 minute, that is equal to 1 by second, right? So minute is converted into second. So here this is the same way, right? So 6000 divided by 60, right? So this is RPS, right? Then force then force coming to the next third units. What is force? Already we know. So effort to change the state of object. So this is force. Simply we can tell it as the force is a effort to change the state of object, right? If you apply a force to that object, it will change the state of that object, right? So that is force. Unit is N, Newton. Already we know, right? So how it will come? Newton. Force that is equal to mass into acceleration. What's the unit for mass? So kilogram. What's the unit for acceleration? Meter by second square, right? So Newton will be equal to kilogram meter by second square. Kilogram meter by second square. Kilogram meter by second square. Yeah, if MLT system, so kilogram, what's the in MLT system, what's the symbol for kilogram? M. What's the symbol for M? That is L. L divided by second square T raised to 2, right? So M L T power minus 2. This is the MLT system for Newton. So in this way you have to calculate. In this way you have to mention, right? So don't memorize it. Don't muck it up, right? So Newton means ML T power minus 2, right? So if you don't know, you can substitute the equation here, right? Newton that is equal to kilogram meter by second square, ML T power minus 2. So what's the unit for moment? So Newton meter. What is moment? So if you apply a load in a cantilever beam at the free end, means so the maximum bending moment at the fixed end. So that moment is called as the unit of that moment is Newton meter. Newton meter. So if the rotational in the rotational object, so this is called as torque, right? This is called as torque. That unit is also Newton meter. So moment means force into distance. So torque means force into radius. So the unit of distance will be equal to the unit of radius. So that's why the unit of moment and torque will be same. So Newton meter, here also Newton meter. So Newton means kilogram meter by second square into meter. So kilogram meter square by second square. So M L square divided by T square. So M L square T power minus 2. So this is the MLT system for moment, right? Work or energy. What is work? So if you give any force to that object, it will move. So that amount of work will be done on that object. This is the concept of work. So Newton meter or joule. If you apply 1 Newton force to that object, if the object will move 1 meter means the total work done is 1 Newton meter or joule, right? Or joule. So this is unit for work, right? Newton meter. So if you substitute the same unit, work and work and energy and moment the same unit. So Young's modulus E. So already you know what's the value for Young's modulus? Newton by meter square. Newton by meter square. What's Newton in Newton is the force unit. M is area. So force by area. So it's the same unit for stress. So Newton by meter square. So here M L T power minus 2 divided by so L square, right? One L will cancel. M L power minus 1 T power minus 2 is the MLT system for Young's modulus, right? Young's modulus. So if you convert, so sometimes they are giving Newton by meter square, that is equal to so stress and the unit for stress and Young's modulus are same. So the stress Newton by meter square. So 1 Pascal they are giving 1 Pascal. 1 Pascal that is equal to 1 Newton by meter square. 1 Newton by meter square. 1 Pascal, right? So what's the conversion from Newton by meter square into Newton by mm square? So denominator same. Numerator same. So 1 denominator meter square. So how many 1000 mm that is equal to 1 meter. 1000 mm that is equal to 1 meter. Here 1 meter will be there. So here 1000. So 1000, right? 1000 power 2 because here meter square will be there, right? So 1000 square, right? So 10 power 6, 10 power 6. Hello, audible ba? Is it audible, Rajesh?
Yes, sir. Yes, sir. It's audible.
It's a target.
Okay, sorry. Right. So shear modulus also having the same unit Newton by meter square, right? Newton by meter square. So here Pascal already we have discussed it, right? So mass moment of inertia and area moment of inertia. Mass moment of inertia, what's the mass moment of inertia? So this is mass into radius of gyration. So this is kilogram meter square. So area of moment of inertia, so this is meter power 4. So polar moment of inertia also having the same unit meter power 4, already we know, right? So apart from some unitless quantities also there, right? Poisson's ratio, there is no unit. Strain, there is no unit, right? Factor of safety, there is no unit, right? So this is lateral strain by longitudinal strain. So in the numerator and denominator, strain quantity will be there. So there is no unit, mm by mm. So strain is also having no unit. Factor of safety, that is, sir, ultimate stress divided by permissible stress. So this is factor of safety, there is no unit, right? So damping coefficient, so the unit of damping coefficient is, so in the dynamics of mission subject, damping coefficient will be there. So Newton second by meter, right? So some damper will be there. So due to that damper, the vibration will be reduced. So each and every damper is having some damping coefficient. So the unit of that damping coefficient is Newton second by meter. Newton second by meter. If you found, you can convert into MLT system, right? So then strain energy stored. What is strain energy stored? So the unit is energy, right? Newton meter. Newton meter. So strain energy stored is Newton meter. So that is denoted by letter U. So unit is Newton meter or joule. Right, Newton meter or joule, right? So the last point, so units derivation in equations, unit derivation in equations. So here some equations of motion will be there. So on the left hand side, so this is final velocity, so this is initial velocity, so this is acceleration, so this is time. So v, that is equal to meter by second, so on left hand side. So right hand side, u, so meter by second, so a, meter by second square, t, that is equal to second, right? So meter by second plus meter by second square into second. So second will cancel, right? So meter by second plus meter by second, again 2 meter by second. So meter by second, so unit for right hand side. So this is unit for left hand side, both are carried, right? So here the second equation, yes is displacement. Unit for displacement is mm or meter. So here we are take it as meter. So if you want, if you take s as meter means, so if you substitute the unit of U as meter by second. If you take S as mm means you have to substitute U as mm by second. The problem they are giving meter by second means you have to convert. You have to convert first mm by second and then only you have to substitute here, right? So ut plus half at square. So meter. So here we are taking meter as unit. So meter, left hand side unit is meter. So right hand side ut. So meter by second into second plus half into meter by second square. So half is not necessary here. Meter by second square into second square. So S cancel. So second square will get cancel. So meter plus meter, again it will be meter. So both are same, right? Meter and meter. So V square. So meter square by second square. Because formula for V is meter by second. So square will be there. So that's why meter square by second square, that is equal to, so here also meter square by second square plus 2 into meter by second square into meter. Okay, meter square by second square plus meter square by second square, both are same, right? So in this way you have to verify the unit in all equations, right? So here del L. So if you want to calculate the del L, what is del L? Elongation of bar when it is subjected to some load, right? Elongation of bar. So that is del L. So if you want to calculate del L in terms of mm means, if you want to calculate the del L mm means, you have to substitute in that way, right? So for example, P. So what's P? Load. So Newton. There is no relation between Newton and here mm, right? So that's why we can keep as it is, Newton. So L, length of the bar. If in the problem they are giving the length of the bar is 100 meter means, so you have to substitute in terms of mm. You have to substitute in terms of mm here, not in meter, right? Why? We want del L in terms of mm. We want del L. So elongation of bar, we want elongation of bar in terms of mm only. So that's why we are going to substitute L in terms of mm only. So if they are giving 10 meter means you have to convert 10 meter into mm first, right? So 1 meter that is equal to 1000 mm. So 10 meter that is equal to 10 into 1000. So 10,000 mm. So you have to substitute 10,000 mm for L, right? So L is the unit of L is mm, right? The unit of area. So here also mm square, you have to substitute mm in terms of mm square, not meter square. Not in terms of meter square you have to substitute. You have to substitute in terms of mm square only, right? So what's the unit for E? That is equal to Newton by meter square, right? So here mm, that is equal to Newton mm divided by mm square into Newton by, here also you have to substitute in terms of Newton by mm square, right? Not in Newton by meter square. So Newton by mm square. So mm square will get cancelled. So Newton will get cancelled. So here mm. So here also mm. So both are same, right? So if you don't know the value of the unit of del L means, if you don't know the unit of del L means, don't worry. You have to substitute. You have to substitute all the units of the right hand side. So Newton. I am substituting Newton. So you are substituting L in terms of meter, right? You are substituting the area in terms of meter square. You are substituting the Young's modulus in terms of Newton by meter square, right? So then you have to cancel it. So finally you can get the unit of del L, right? Finally you can get the unit of del L, right? So this is strain energy stored. So this is strain energy stored. What's the unit? So Newton meter. So strain energy stored is Newton meter. That is joule, right? So what's the unit for sigma? Sigma is stress. So sigma square. So Newton by meter the whole square divided by 2E, Newton by meter square, right, into volume, so meter cube. So 1 Newton by meter square, 1 Newton by meter square will get cancelled. Okay, right? So 1 Newton by meter square will be there into meter cube. So meter square will be cancelled. So finally Newton meter. So it will be same, right? Newton meter and Newton meter, right? So then what's the instantaneous stress during the weight fall? So this is the formula for instantaneous stress during the weight fall, right? So Newton by meter square. So right, root of E. What is E? Newton by meter square. So P, that is Newton, H, that is meter, divided by A is meter square area. So L is again meter, right? So Newton, so that is equal to root of meter square, 1 meter, here 1 meter we can cancel. So Newton square divided by meter cube, okay. So that is equal to root of Newton square divided by, so this m will come to the denominator, meter power 4. So root of it, so Newton by meter square. So this is unit for stress, instantaneous stress. That's all, right? So what is theory of bending? So this is sigma by y, m by I, E by r. What is sigma? So this is stress, right? Bending stress, y. So this is the distance of fiber to the neutral axis, right? So at which the fiber at which we are going to calculate the bending stress. So that is the fiber. So the distance between that fiber to that neutral axis is called as y. So that is equal to m by I, bending moment divided by I, in smallest, that is equal to E by r. You can check it up. Right? You can check it up. So sigma Newton by meter square divided by meter. So Newton by meter cube. In all the values, this formula will come. So this unit will come. So this is Newton meter. So divided by meter power 4. So this is for I. Right? I is meter power 4. So what will be there? Newton by meter cube. Here Young's modulus. Young's modulus is Newton by meter square divided by R. R is radius of curvature. So that is meter. So Newton by meter cube. Right? So in this way you can check it up. Right? Right. So to familiarize with the units of your engineering. So this is theory of simple torsion. So T by J, tau by R, that is equal to G theta by L. The same way. This is the same formula only. So this is for torsion. So T is Newton meter. So torque. So divided by J is polar moment of inertia, meter power 4. So Newton by meter cube. So that is equal to Newton by meter square divided by R is meter. So Newton by meter cube. So here G is shear modulus. Unit of shear modulus is Newton by meter square. Into theta is radian. So there is no unit for radian. Or sorry, here there is no unit for theta. So divided by L. So meter. So Newton by meter cube. So this is, so the angle turned, angle of twist. So there is no unit here, right? If you tell what's the unit of this physical quantity, so you note it down. You can tell what's the unit of this physical quantity. So with this slide, I will close. F pi d cube. 8f pi d cube. And we can tell what's the unit of the final unit of the left hand side physical quantity. So Ks spring constant. So Ks spring constant. So there is no unit. So because, so this is 2c plus 1 divided by 2c. where C is D by D. So this is mean coil diameter, D is the wire diameter. So mm by mm, there is no unit. F applied force Newton, D mean spring diameter, mm wire diameter, right? What's the unit? What's the unit?
Newton per mm square.
Newton per mm square. So this is shear force induced during deflection of helical spring. So shear force, so tau. So this is nothing but tau. Ks into 8F divided by pi d cube, right? So if you in the problem, if you are not so you are not knowing the unit of tau means, don't worry, you have to substitute all the values. So the unit of the quantities in the problem itself, right? The problem they are giving F, Newton, D, so in mm, right? So you substitute. So Newton, mm divided by, there is no unit for pi, mm cube, so Newton by mm square. So this is the unit for tau. Okay, thank you. If you have any doubt, please ask. So yes.
Sir, yes, sir. Sir.
I finished the Tajesh.
So participants, if you are having any doubt,
please ask.
You can either type it in the chat box or you can directly ask your expert speaker. Any doubts regarding today's design conversion or yesterday's session also, you can ask your expert speaker. Okay, so I think there is no doubt from the participants, so I think we can formally end the session. Right? So Prajesh, please take the session.
Okay.
Thank you, Gururaj sir, for your nice presentation. Very wonderful, sir. Nice presentation.
Thank you, sir. Thank you.
Oh, thank you, Gururaj sir. So as we formally started our today's webinar, so we close the section formally. Now I like to welcome Mr. E. Vasisthar from Final Year Mechanical Engineering to propose the vote of thanks for the today's session.
Very good afternoon, good evening to one and all gathered here. I deem it a great honor and a privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our chief guest, Mr. C. Gururaj, Assistant Professor, Department of Mechanical Engineering, Ramco Institute of Technology, who despite his busy schedule has found time to grace this occasion. And I also express my heartfelt thanks to Mr. J. Jebint, Assistant Professor, Department of Mechanical Engineering, Ramco Institute of Technology, who giving us the opportunity to conduct this type of events. We are grateful to our principal, Dr. L. Ganesan, Ramco Institute of Technology, for his words of encouragement. His able guidance has always encouraged us. I thank him for his kindness, his interest, his hospitality, and continued support. I thank our Vice Principal and also a well-wisher, Dr. S. Rajakarnagaran, Head of Mechanical Department, Ramco Institute of Technology, for his stewardship, support, vision, and commitment. I thank our Principal and Vice Principal for their unstinted support for this function. My heartfelt thanks to the faculty members and student coordinators for their valuable contribution, guidance, and encourage in all our efforts. I owe special gratitude to the non-teaching staff who have worked hard to ensure that this occasion becomes a memorable success. I thank all the distinguished invitees present here accepting our invitation. Last but not the least, I thank you, my friends, for your cooperation in making this function a resounding success. Once again, I thank you all for your attention. Thank you.
Thank you, Mr. Vasisthar.
So thank you participants for joining with us today. So tomorrow we are having another session, that is units in thermal. So we are expecting your participation tomorrow also. It will be very useful for you. So hope it will be a wonderful session for you all. So thank you once again for joining with us today. Thank you.